Hello guys, welcome back. So today we are going to see the Leetcode question, that is we have 2477. Okay, and let's read this question. The minimum fuel cost to report to the capital. Okay, this is the question we have. So let's read the question. Question is saying that there is a tree, okay, and it is connected undirected with no cycle, right? It is connected means what? All the nodes are connected with each other. Undirected means there is no direction is given, right? And there is no cycle. It means it is not maintaining a cycle. Okay, now what we have to do means we have to say 0 to n-1 as we have to we have already given, right? Nodes we have given. Then we can say there is a tree structure country network. Structure country network consists of n cities, right? How many cities? N cities we have consist it, and it is from 0 to n-1, right? As I told you, right? So total n-1 0 to n-1 you can say numbered cities we have, right? It is connected, and exactly n-1 roads we have, right? So this is our edges, you can say, that is connecting to this, right? See how you will understand the question, right? Question, if you'll read the question, you will understand. If this is connected undirected and there is no cycle, right, it means there is n-1 edges is the possibility. Okay, and it should be, how many nodes should be there? N nodes should be there, right? So if you want to represent the all these nodes, so you can say total node is what? 0 to n-1. And see, the same question it is saying, right? So this is a tree and a structure country network it is, and it is consisting of what? N cities, right? From 0 to n-1. And exactly how many roads we have? That edges that we are talking about, n-1 only, right? So this is completely a you can say tree problem we have, right? So what is saying that the capital the capital city is city 0, means root node is what? 0. You are given 2D integer array, that is roads. Okay, so total roads we have given, and all roads connecting with another one city to another city, right? That we have given here. Okay, and it denotes the bidirectional road and connecting city A to B and B to A, that is possibility, right? Now it is saying that there is a meeting for the representative of each city. The meeting is in the capital city, right? Means at the root, and there is a car in each city. You are given an integer city, you can say, that indicates the number of seat in each city. Okay, so there is a meeting for the representative of each city, and meeting is in the capital city, right? Capital city is what? City 0. Now it is saying that there is a car in a city, in each city, right? There is a car in each city. Now what you have to do? You are given an integer seats, right? We have given integer in the seats, and that indicates the number of seats in each city, right? Number of seats in that car, in each car, in each city. Okay, we have given. Now what we have to do? Representative can use the car in each city, in their city, to travel to change or travel or change the car, and write another representative, right? Understood? Means representative can use the car in their city to travel or change the car. They can do to change or travel and ride with another representative, right? So the cost of traveling between the two cities is 1 liter of fuel, right? One city to another city, cost of traveling from between two cities, 1 liter of fuel. Okay, now what we have to do? We have to return the minimum number of fuels, right? Minimum liter of fuel to reach the capital city, right? Got it? Now think about it, right? This is the example we have. Okay, example first we have, right? So in example is saying we have node, what we have? 2 we have, 0 we have, 1 we have, and 3 we have. Okay, so roads is given, how it is given? 0 1 first integer, you can see in the on there, right? First we have given 0 1, second we have given what? 0 2, and third we have given 0 3. 3 entries we have in rows, right? How? 0 to 1 means this is the thing he's saying. 0 to 2 means he's saying about this one, 0 to 2, and third we have given 0 to 3. Okay, so total how many cities we have here? N equal to what? 1 2 3 4. Total 4 cities we have given, right? N equal to 4, right? So edges is what? How many edges we have given? N minus 1, that is what? 3. So count 1 2 3, that is we have given, right? That is why I was saying that if it is saying connected and it is not cyclic means n minus 1 edges we have. If n equal to n means there is some cycle is there, right? Now understand, we have given road, right? This road is given. Now we have given seat, total seats are 5. Okay, now how we will find our what is we have to find? We have to find the minimum number of liters of fuel to reach the you can say capital city, right? How will reach to capital city? Okay, the representative, let's suppose there is a man, right? Let's suppose this is a representative. Okay, so representative goes directly to the capital city with 1 liter of the fuel, right? He has 1 liter, right? He has gone to 1 liter. He can go to any places, right? He has. So representative 1, let's suppose we have here, right, this position. So he can go to here, right, with a 1 liter, right? Now from 0 he can go to this any on this one, right? Any this one, right? So if the representative at here 2, so he can come to with 1 liter. Each representative have, so he will take 1 liter. He is also taking 1 liter, and from 3 it is also containing 1 liter. It will take 1 liter. So because 0 is in the middle, right? So all will take what? 1 liter, and so you can say 1 plus 1 plus 1. All 3 representative for each city we are counting and we are returning as a value, right? So it costs 3 liter of the fuel at the minimum, so it can be reached to its capital city, right? The 3 minimum liter we have to store. Now see the example 2. Now center is what? Capital city is what? Here. So everything we have given, all the roads connectivity is given. So we will see the graph directly. Okay, as you or you can see the roads also here, and seats we have given. So total seat we have given 2 here. Okay, now what we will do, let's suppose we have a representative, right? From we'll take from this position. Let's suppose we are going from here. So if representative 2 is going to here, right? He is taking 1 liter. Now he is taking 1 liter, and now he is taking 1 liter, right? So total representative 2 will go and it will take what? 3 liter is taking, right? Now let's suppose representative from here, right? Let me change the color, right? So will you understand? Second time representative 3 is going to here, right? So how many liter he will take to reach this position? He is taking 2. So 3 representative 3 is taking to reach to 2 liter with the 2 liter. Like this, if you will do the sum, right? So this will take what? Representative 1 will take 1 liter. Similarly 5 will take 1 liter. Now if we talk about 6 will take 1 liter and 1 liter. So how many liter we have? 6 is taking 2 liter. 4 will take 1 liter. 4 will take 1 liter, right? So if you'll do the sum, how many what is the answer will we have? So see, it will become more harder to calculate like this, right? It is taking 4 liter, 3 liter, 2 liter, like this it will take, right? So if you do the calculation, right, for the representative, right? So you can see representative 4, right? Representative 4 and representative, where is the representative 6, right? This one, right? It is taking what? 1 liter and 1 liter you can say, right? It is taking. and then if we'll count from here to here directly, it will go to what, which location, 1 liter. So we'll say it is 4 is taking what, how many liter, it is taking 1 liter, and 6 is taking 2 liter. So we'll say, let's suppose we have what, 3 liter we have reached here. And if we'll talk about 5 is taking what, 1 liter, now 4, and this one is taking what, how many liter, it is taking 1 liter. So total is what, 5 liter. Okay, on next this 2 liter will count, right? So it is taking what, 2. So total is how, 7 liter will have, right? So total it will count 7 liter. Okay, but if you will start with here, first we will take 3 liter, then we will take 2 liter, then we will take 1 liter, then we will take this liter. So you will complete here only, 7 liter is completed. Now these two will not get completed. Got it? Let me repeat again. Let me re-summarize this one. Okay, see why I'm taking from this side. See, it is taking what, 1, it is taking what, 1, it is taking 1. Okay, so we'll take these 3 first, suppose. Now we'll come to here, this is taking what, 1, so we'll add 1, now it is 4. Now this will take what, 1 liter, so we'll add 1 liter, now it is 5. Now it is coming what, this one, how it is coming, 1, 2 and 3. So if we'll not count this one, right, and if we'll count this one, right, so this is already counting, right? So what happened, from 4 we will not add 1, we will not take this one, this step, we'll take these 3, right? And so that if we'll do 3, we are getting 7, and we are completing, we are traveling all each other, right? The representative will reach each other. So in the 7 liter our work can be done, right? Understood? So this is the way we have to find the minimum distance, right, of the you can say to reach the capital, right? Total how many liter we have to find, that we have to do like this. Okay, let's go for the example 3. Example 3, we don't have anything, right? Is road we don't have, but street we have. So if the road is not there, how where we will travel, right? So we have to return 0 as a answer. No representative can travel from each city. Now think about, give me 1 second. Yeah, so let's suppose what the question. So see, we have given a tree that have how many nodes we have, n nodes we have given, right? And for all the n nodes, right, nodes is nothing but our cities, you can say, right? If you will say, so total n cities we have given, right? N nodes we have given, n cities we have given. So this can be possibility is what, how many we have, 0 to n minus 1. As I told, this is connected and not cyclic, right? Other, we can say this is exactly how many edges will we have, so n minus 1, right? So if we'll say there is of 5 node, right? So total how many edges will be there, 4 will be there, and from 0 to n minus 1 cities will be there. Okay, so 0 to n minus 1 cities means total, if there is 5, let's suppose 5, so total 0 to 4 will be there, right? 0 to 4 cities will be there. Got it? So if there is a car, right, if there is a car and one of the representative want one of the representative at each node, right, we have, right? So what we will do, we will have the seats are given, right? Seats are given. So what we will do, that each representative, right, each representative, or it will do what, maximum number of you can say find the representative that can together can go in any car, right? See why I'm saying this one. So as you remember, when I was doing this approach, right, example second, third, okay, example second, when we are doing, so what we are doing, when we are traveling from this side 2 to 3, when we are traveling to 2 to 3, then what happening, I'm going with along with this one, and so that we don't need to count this one, right? If a representative is going from 2 to the capital, like this he is going, right, like this he is going, he is reaching to here, right? from 2 to he is going to capital city 0. At that time, if 3 is coming in this way, right? If 3 is coming in this way, then how many count is there? See, 1 2 3. So we don't need to count 3 to 1. We don't need to count, right? 3 to 1, and we'll say that while coming with him, 2 seats is there, right? So 1 seat is for who? 1 seat is for this 3, right? Will take, and 1 seat is for this 2. So representative 2 and representative 3 can sit with its 1 seat is occupied with this one and 1 seat is occupied with this one, and so that seat is occupied, right? So when he is coming to the capital, this car is full, right? This car is full. And when he is coming to, he saw another representative at this 1, right? So seat is not available, so he is not counting this one, right? At that time he is not saying you can't sit here, right? And so that we have to take one more steps here, right? 1. That's why after counting these three, right, here, what I am doing, I am counting one more step, 3 and plus 1, right? And that's why this is we are counting like this. Okay, so let me recap again so you will understand very well. Okay, what I am saying, that while we are going from here to here, right, in this path, right, we are starting from what, 2 and going to center, this here, right? So how many steps we take? 1 liter, 2 liter and 3 liter. Total 3 liter we have, right? So, and how many seat is there? 2 seat is there. One seat is occupied with his, so available seat is what? -1 we will do. Available seat is 1, right? So when we reach 3, representative 3 will say, I also want to go to what? Here, in the capital city. So what we will say, yeah, 1 seat is available, you can sit here, right? So he is while coming, he is not going to pay any liter of the fuel. So he is coming along with him, so that is okay. Seat is available, he can go, but there is no liter is counted, right? Because representative 2 is already coming, so he can use that one, right? Now when he's come to 2, he said, I also want to go, but there is no seat is available, so seat is not available, right? Seat is now 1 minus 1, that is 0. No seat is there, right? So he can't sit here. Here he can sit, here he can sit, but here he cannot sit, right? So once he is coming to 1, right, there is no seat, so the representative 1 cannot sit here, and so that he has to pay 1 liter, and then he has to come to what? This capital city center. Similarly, now it is what? 3, and it is taking representative 1 is taking what? 1 liter. This here representative 1, we have seat 1, he is coming to here, he is reached there, right? So total now is what? 4 we have liter we have for here. Now it is coming to, from 6 it is taking 1 liter, from 2 it is taking 1 liter, and from 3 it is taking 1 liter to reach this capital, total 3, and that's why we are taking 3, right? So total is coming 7. Now you got it. So what I am saying, that so there is 1 car and 1 representative at each node, right? And we are given what? Integer seats, right? Like 2 we have given here, right? So it represents that the maximum number of representative at here, right, that can be together go in a car that we have in the seat, maximum seat that we have here, that he can go. Like you can see, that's 3 can go with along with the representative 2, right? But 1 cannot go because there is no seat. Okay, so the cost of traveling over an edge using the car takes 1 liter of a fuel that we have seen, right? Now understand, our task is to move all the representative to node 0 by using the minimum fuel, and we will return the minimum fuel required to do so, right? Means our task to move all the representative to 0 node, right, that is capital city, by using the minimum fuel that we have to do, that we have seen 4 we have counted, 3 we have counted, and we are seeing that 7 will be the value, right? So this 7 is very, very important, because see, we are using what? 3 and 4 minimum fuel we are using, and if we are not counting this, then obviously it will go to max fuel, right? Max fuel will happen, but we have to find minimum fuel so that our task, we have to move all the representative in such a way to reach to capital city node 0, so that we can find the minimum fuel, and we will return the minimal fuel required here, right? Now you have understood this one, right? Now what we will do, we'll say we'll take some you can say you have understood the depth first search, right? So the approach we will take, like we have given like this. Okay, so let's see, we have one example. Okay, let's suppose we have example, we have given 0. Okay, so this is our, let's suppose this is our root node. Okay, so 0 is our root node. So 0 has 2 kid. Okay, this 0 has 2 kid, that is 1, we'll set 1 and we'll take 2 or 3 will take. Okay, 0 1 2 we have, right? So this 0 has 2 kid, right? And so it will take another kid also, right? That can be possibility. Let's suppose 5 and 6. Okay, 5 and 6 we are taking. Here we are taking 3, we will take 4, maybe 7 8 will take. Okay, like this. If we'll this is have what 6 we have, and this we have 7, right? This 6 this is 6, right? So we will take 7 and 8. Okay, like this we'll take. We have one more, we have 9 here, right? So let's understand, this is the graph we have, this is the tree we have, let's suppose we have given. Okay, so this is a level 1 we have. Okay, this is at level 0, this is at level what 1, this is a level of 2, this is a level of 3, and this is a level of 4, right? So in this way, what we will do, we will define our level, right? And if we'll talk about for the 0 node, right? For this 0 node, this is our child, right? This is our child, you can say, or you can say a subtree of node 1. Okay, we can say. So these things you already know, right? So you already aware with the child node, right? What are the descendant node are there, subtree is there, right? What is the levels are there, right? So these things we have already known, right? If you have not understand these things, so you can do some search on the Google, and you can find what is level, what is descendant, what is subtree, right? You will understand. But basically you have to understand this subtree is a part of this node. Okay, so now what approach we should use? Okay, first we will use let's suppose you can do with depth first search, DFS, right? So in the depth first search, right, what we will do, we can think like when we are taking a car, right, and we are going from, let's suppose this is the example we have, right? Let's suppose we are going from any, if you will do the marking, right? Let's suppose, okay, if you'll define the level, this is at level what 0, right? But if you'll do the representation here, right, this is very hard how to implement this one. So if you'll represent this one, so 0 we have here, right? Now from 0 what is connected, 1 is connected. Now another kid is what, 4 is connected, and next kid is what, 5 is connected. Okay, now if you'll see 4 is connected with what, 6. So we can say there is a kid of this one, that is 6. 1 is connected with 3, so I'll 3, and 3 is connected with 2. Okay, like this total we have. Okay, and for this okay, and for each level, right, this is our 1 we have. So this is our level 0, this is our level 1, and this is our level 2, and this is our level 3. Okay, so these are levels we have given, right? So if someone is taking a car from level 1 and it is going to down, right? So how many he can take, right? He can take he can count from level 1 to he can go down, right? He can take the previous, he's already done 1, now he can take 1, right? So if want to go back, right, to the level 1, right, what we have to do? That is pointless, right? We cannot go back and we'll say that we'll store, right, the value, right? So it takes 2 unit of the fuel to go to what, from 1 to 0 node to, you can say, the node 1, right, parent 1. So this way we will try to implement this one. Okay, so what we will do, let's go to the browser section and we'll try to implement this functionality. Okay, okay, so we are here. What we will do, we'll implement this functionality of DFS. This is about DFS search. Okay, and we are going to implement this one. Let's suppose we will take we have taken what, we have road we have given and sits we have given. Okay, so what we will do, we'll take first of all adjacent matrix, right? So we'll take into we'll have about what nodes we have given. So we will take all the nodes, its adjacent node, right? We have 0 is connected with what, 1, 4 and 5. So it is connected with a list of nodes. So I'll take map, right, and first we'll take node, that is integer, and it's all its neighbor node, right? That is, you can say 3, 4, 5 and 1 was there, right? So this is our adjacent and then we will say new has map, correct? This is done. Now what we will do, we'll make a for loop and we'll say we'll traverse to its we will try to initialize this one, you can say. So we have given roads we have given, so for each road will take each road, right, is coming from what, roads, right? So we will initialize for each road, right? So we have adjacent, right? So on the adjacent we will add, we know how to do that, right? We will do compute if absent and we'll put what, first the each road will pass, each road we have, so each road means single road at a time, right? This one 0. So road 1 will contain what, some value. Okay, and let's suppose we have item, you can say item, or you can say what we can say, neighbors, right? So if we have neighbor, NEI neighbors, so this neighbor will go, NEI will go to map to it's you can say a variable, right? Or you can say we have to take all the neighbor list, right? So neighbor list can be a array list, right? So this will take all neighbor nodes, right, like this. Now once it is done, we will add on here each road we have, and each road contain at first it is at 1 and that is for 0, right? So two time it will come at road 0, because see this is edge, so for each one 0 and 1 will be there, right? I think you have understood. Okay, so first it will come for node 0 and node 1. So let me say, if you're writing edge, right, if you're writing edge, so there is a 0 and there is a 1, right? And so that we are taking 0 1, okay, for 0 and 1 we are taking, right? Now this is done, right? This is for 1, you can say we have to interchange, right? For node at 0 edge 0 means this is the road we have, right? this is edge we have. We are getting all the edges from the roads, right? This is 2D and we are getting one by one here, right? And so that we are doing. Okay, now this is done, this part is done. Now we'll create on DFS utility method, DFS utility method, and we'll pass what, the initial will start from 0. Let's suppose initial source we can say, then we'll take -1 its index, and adjacent we will pass, yeah, ADJA, adjacent we will pass, and then the given seats, right? These are we have given. Now what we will do, once this is done, we should take one output, like how many fuels will take. So let's suppose we are returning fuel, right? So number of liter, right? Total fuels, you can say total fuel, how many total fuel it will take, minimum total fuel, right? Minimum total fuel that we have to return. So this is nothing but the long, right? So we will return. So we will update this one through the DFS utility method, and so we should take outside of this class. So we'll take long and we'll pass here. Okay, we'll create the DFS utility method now here. So see, it is not returning anything, right? This method is not returning anything, but it is updating the you can say what we can say, the fuel. It is updating the fuel, and so that if it is updating the fuel, means we have to update its we can say return type, right? So we'll say there is a public method we'll take, and this is long type, so that it will update the fuel. Okay, and method will remain the same. Okay, so first it is we are passing what, 0. This is our initial node, right? So this is our node. Then we will pass our what is its, do you have the parent, right? If it is have the parent, or you can say index also, right? So for each index you will understand what is the its previous parent, right? Now if we will have each node have the parent, right? If yes or no, he can go to that node, right? Now we'll take what, map, and this map is nothing but our, we can take here to here, adjacent. This is our nothing but adjacent. This one, and set is nothing but our integer, so we will pass int. This is done. Now what we should do, we will do if node has itself value, right? That let's suppose we'll take a representative, and we'll say that is, we'll start with 1, and we'll say that if this adjacent, if this adjacent contains our node, right? If this node is contains, right, then we will do. If not, if this is not, means what we will do, we will return 1, right? We will return, or we can say this representative we have to return. Okay, we can do that, right? If not, then what we will do, sorry, if not, okay, if not, then what we will do, then we will, if it is not connected, if this node is not there, then we will return 1, and if we have, then we will go to all its neighbor, right? We'll make loop, adjacent we have dot, we'll do get, and we'll file our node. If node we have, then what we should do, we'll get all its neighbor, int neighbor, or you can say here neighbor is nothing but it's all child nodes, right? So you can say child nodes, right, we will get one by one get, and we will make on its loop. You can say never also. Okay, now if node we have, right, the child node we have, this node will take what, not equal to parent. If it doesn't have the parent, if it is not equal to parent, you can say not equal to parent, it is not equal to parent, then what we will do, we will add some count on the representative, and we'll say that each child subtree has to go with the parent subtree only, right, the level wise, right. So we will add the count of the representative in each subtree to the parent subtree, right. So how we'll do, we have representative, right. So this representative we will update equal to what is coming with this DFS, right. It will check its sub children, right, because in one depth we will check all its children. So here node is what, we have child node, and do you have parent? Yeah, currently parent is node. See, node, child node is coming from what, adjacent dot get node. So this is our parent and this is our child node, right. Now adjacent will remain same, seat will remain same. So each time your representative will get updated. So initially one representative has started then with the position, and when it's moved to its next level, right. So see, we have already seen that one, right. I think I have removed. Okay, on the level wise, right. So level wise what will happen, let me go here. What I'm trying to say, so I'm saying, like, we have some parent is given, right. Let's suppose we have 0 is given, in the next we have 2 we have given, 3 given, 4 we have given, 5 we have given, 6 we have given, like this. Okay, so what will happen if this is the parent, right, this is the parent. Okay, so this is a level, right, this is the level. If he is coming from here to here, right, so when we are, let's suppose we are talking about 2, right, when we are talking about 2 means we'll do what, adjacent dot get node, and this node is what, 0 in starting. So node is 0, and if we'll do get, how many children it will come, it will come 2 and 3 it will come, right. So what we will do, we will check first if child node is not parent, means this 2 is not what, this 0, and then we'll pass again the DFS, we will do this DFS, right, this DFS, and we'll say we will do same thing that we have done till now, right. Representative is currently is what, we have 1 when we are coming to here. Okay, and this time what will happen, we'll check what, node, right, we'll pass our children node, this node, and we'll check the next children, its next children. For the next children, it's the next level we'll find, right, next depth. We'll pass the children node, and we'll pass our node, parent node. Okay, so that what will happen, we will get some value, it will return some data. Let's suppose it is having 3 liter, it is taking child. So this is returning 3, already representative we have 1, right. So how many representative it is taking, let's suppose it is returning 2 representative, 1 for here, 1 for here, right. 2 is coming already. So if this is going up, right, so it will not count this path, it is containing what, already 1 is there, and this will not take 1, and this is coming from here, so it will not take again this one. Okay, so what we will do, we will update our representative as 1 only, and we'll say this sub children, this is what, children node, means we are talking about this part. If it is have some, how many representative is it returning, so we will update our representative at that time. Okay, this representative taking how many liters, right. So we will have the ability here. Okay, now coming to here, what we will do, once our we will adding all the counts to the representative in each sub children, right. and then a subtree of the children to the parent subtree. Okay, so you all the representative will get updated here, right? Now what we will do, we'll check once it is done for all the neighbors, right? Neighbor node, or you can say children node. Then what we will do, we will have our current node, that is parent. If parent not equal to 0, what does it mean? Means we are doing count not equal to node is not equal to 0, means we are we will check the total count of the fuel to move to the parent node. Okay, and we'll check the root node does have any parent. If have, then we try to ignore it. Okay, we should ignore it actually. If this is a root node doesn't have any parent, then we will ignore, we not need to do anything. So we have taken what? Minimum fuel load, right? Minimum fuel we have taken, right? So that we have to update. How we'll do that? We'll do plus, and then we'll pass what? The selling value will take math dot sell, and then we will pass what? Representative, how many representative we have, and then total seats, right? Then we will do. So once we will divide this one, right? So it will return into what? Double. So what we will do, we'll pass in double, not like this actually, we have to do like this actually. Okay, so this will return what? Double. So we are typecasting this one. Okay, we can take into, this is also in the folder. We'll take here. Okay, so representative and seats we will divide, and we'll say we will typecast with the this one. Okay, once it is done, what we will do, we will return our representative, because we are updating representative only. I think so. What I'm doing wrong, I should do double this one. Maybe it is not updating, right? Yeah, correct. Thank you so much guys. If you like this video, please hit comment, subscribe this channel. Okay, so now let's talk about the complexity. Okay, so total time complexity is here. What we are taking? On, right? O of n we are taking time complexity, and for the space complexity we are taking what? O of n. Why we are taking O of n? See, we are going to see all its node, right? For each time we will visit each node, right? In the with the DFS, right? You can see DFS utility will go with all the nodes, right? We are passing a node, right? And each node will take what? O of n time in the total, because we have to go with all the nodes, because we have total n-1 undirected edges, right? So for each edge we can only iterate twice, one for its 0 and another for 1, that we are seeing, right? 0 and 1 we are going, right? So if we do the result of this total operations, it will take O of n only, right? So we'll need O of n times to initialize our adjacent also. In the space we are taking what? One extra we are taking this one of the same size of what we have. So total O of n space will take, and we'll do the recursion over this you can say DFS, right? And so that will take total in the worst case it will take total n elements, right? And we'll say that O of n will take as a space. Okay, so let me write TC and SC both will take what? O of n. Thank you guys, thank you so much. Please hit subscribe and like this channel.